Certainty principle. The greater the knowledge of the interrelated parameters and states of a particle is, the greater the certainty about its other states and about the whole. Uncertainty principle versus certainty principle. For me, the uncertainty principle is an unnatural or illogical postulate or axiom, and also depressing, because it sets limits to human intelligence, when it doesn't incite us to abandon and doubt that intelligence, and invites us to stop at limits that we cannot exceed. Stop, relax, from here on the cosmos forbids you from continuing to measure and investigate. As we see, a little sad, or perhaps cowardly on our part. Although deep down it's something worse, justifying results incomprehensible to quantum mechanics. Heisenberg's uncertainty principle states that it is practically impossible to simultaneously know, with arbitrary precision, certain pairs of physical variables of a particle, such as its position, x, and momentum, p. The greater the precision of one measurement is, the greater the imprecision of the other. This is an axiomatic and unnatural postulate, physically and mathematically, since measurements and their adjustments require the use of primary parameters such as position, x, and time, t, to arrive at composite parameters such as velocity, v, and momentum, p. For simultaneity, s, to exist, we need a reference time and a connection s, x, t. We cannot justify the principles by arguing, as is often done, that if we send a beam, photon, or wave of high energy necessary to determine the position of a particle, A, the energy received by this particle would change its momentum, and it would then have a different momentum. Yes, of course, but the new measurement of momentum wouldn't be simultaneous at s, x, t, but rather at another position, x, and time, t, s, x, t. Now, to make a quasi-exact measurement of velocity or momentum, which are composite parameters of space and time, and mass, we need these adjustments on which velocity and momentum are based to be as accurate as possible. Therefore, in composite structures like linear momentum, P equals m. dx, t, dt, a better understanding of the components will lead to a better understanding of the result. For example, in the linear momentum of a particle, a better understanding of the position, x, in coordination with time, t, and the matter of the particle will lead to a better understanding of the linear momentum, p. But we cannot adjust the simultaneous linear momentum at xt without knowing these parameters, xt,